I have a couple of situations that I want you to consider. Situation number one is this. If it's true that either Sam is going to buy a new car or his family is going to disown him, and Sam didn't buy a new car, does it have to also then be true that Sam's family is going to disown him? Is Sam's family going to disown him if it's true he didn't buy a new car and it's true that either he's going to buy a new car or his family's going to disown him? Now consider situation number two. It's still true that either Sam is going to buy a new car or his family is going to disown him. But now Sam bought a new car. Does that mean that it has to be true that Sam's family is not going to disown him? Okay, so we recognize we've got these two situations. They share a feature in common. That is, in both situations, either Sam is going to buy a new car or his family is going to disown him. In situation number one, he fails to buy that new car, though. And in situation number two, he does buy the new car. So knowing these truths, can we determine in these situations what Sam's family status is going to be? Are they going to disown him or not? Okay, now you recognize here that essentially these situations are arguments. We're being told there's two things that are true, and that therefore something would follow with logical necessity from those two things being true. These two premises are true, therefore this conclusion would be true. And we can determine Sam's family status by creating truth tables that represent these two situations. So if S represents the statement Sam is going to buy a new car, and D represents the statement Sam's family is going to disown him, then situation number one looks like this, where we have S wedge D, tilde S, Sam didn't buy the new car, therefore D, Sam's family is going to disown him. We can assume the truth value of the conclusion being false and the premise statements being true, and then we just deduce all of our logically necessary truth values. And when we do that, look what happens. We run into a contradiction. Okay, so we're assuming tilde S is a true statement. And if that's the case, then S has to be false. And if it's false here, it has to be false there, which means in order for this wedge to actually be a true statement, D has to be true. But we're working from the assumption that D is false, and D can't be both true and false at the same time. And what we've shown here is this, is that when the first premise is true and the second premise is true, the conclusion can't be false. In other words, it can't be false that Sam's family is going to disown him if it's true he didn't buy that new car, and it's true that either he was going to buy a new car or his family is going to disown him. But let's look at what happens in situation number two. We've got the same simple sentences making up this argument. And when we create our indirect truth table to represent this argument, assuming the conclusion statement is false and all the premises is true, we're able to successfully deduce all of the logically necessary truth values without running into contradiction. Okay? What does that mean? It means it's not necessarily false that Sam's family is it's not necessarily false that Sam's family is going to disown him just because he bought that new car. Maybe they still will disown him. D right here is true. And D is true. Sam's family is going to disown him when the premises are all true. So maybe what happens is Sam stole the money to buy the new car from his family. His family said, yeah, the original agreement was either you're going to buy a new car or we're going to disown you, but we were assuming you weren't going to steal the money from us. And because you did, even though you bought that new car, we're still going to disown you. Okay? So what we've shown here is that when we're presented with situations like these, we can translate these arguments, use our indirect truth tables to determine whether or not the conclusion statements would have to be true or false when we assume the premises are true. Okay. Now, there's another way to evaluate arguments like these, and that is to examine the form of the argument. You'll remember when we were studying categorical logic, we spent a lot of time on argument forms, on forms of categorical syllogisms, and we'd determine their mood and their figure, and we'd wind up with some combination of letters and a number. And we could use those letters and that number to consult our inventory of valid forms to determine whether or not a given argument was valid or invalid. Now, we're going to do a similar kind of thing here with propositional or truth functional logic, except we're not going to be using mood and figure. We're going to be using a very different method for determining the form of our arguments and determining whether or not their validity, and that's what we're going to focus on in this thought primer.